बिस्मिल्लाहिर्रहमानिर्रहीम। प्रोटेक्टिंग ग्रुप का चैप्टर हम पढ़ रहे थे लास्ट टाइम। सो उसके अंदर ईथर्स एज अ प्रोटेक्टिंग ग्रुप ऑफ अल्कोहल्स हमने काफ़ी सारे उसमें से ग्रुप्स डिस्कस किए थे। दो आज डिस्कस करेंगे, जिसमें एक है मेथॉक्सी मिथाइल ईथर और दूसरा है मिथाइल थायोमिथाइल ईथर। कोर्स आपको पता है, रोल ऑफ प्रोटेक्टिंग ग्रुप इन ऑर्गेनिक सिंथेसिस है। And my name is Dr. Tahir Makbool. So first of all, the objectives. Here we will study the installation, characteristics, removal and application of methoxymethyl ether and methyl thiomethyl protecting group for hydroxyl groups. So first one is methoxymethyl ether. कुछ key features देख लेते हैं. Methoxymethyl ether is somewhat sensitive to acids. Somewhat sensitive mean it has not a larger pH range below 4, so it is stable between 4 to 12 pH. It is also stable to nucleophiles, mean if you can incorporate MOM group on a substrate, you can subject this this substrate to nucleophile organometallic reagents. It is also stable to hydrides. To some extent it is also stable to catalytic hydrogenation, except in acidic condition. It is also stable to oxidations. So here is the installation. I have draw here the most common method for the installation, that is alcohol is being treated with MTM chloride, that is methoxymethyl chloride. In the presence of ethyl diisopropylamine, you can get your alcohol protected. This is the most commonly employed procedure for the introduction of MOM group. However, there is a drawback. The chlorodimethyl ether, that is the reagent which is being used for the protection, is reported to be carcinogenic. Similarly, in some cases there is a byproduct which is dichlorodimethyl ether, which is also even more toxic. So in order to use this reagent for the protection of alcohols, you need to be much more careful. So there are another preparations in which there is no byproduct like dichloroether has been reported. So you can also follow that method which is reported in the literature. But here I have only described the most common procedure. So come on to removal. And once you have protected your alcohol with MAM, you can subject it with aqueous acetic acid, and using sulfuric acid in a catalytic amount, you will get your alcohol back. Or you may also utilize methanol in the presence of HCl. Here is the application. I have drawn an application of the methoxymethyl ether in CHEM synthesis. Look at this diagram, scheme. The free OH group in 42 was converted into MOM group here by using MAM chloride in the presence of diisopropylamine to get the product 43, which is MOM protected group. Synthetic manipulation over 15 steps. Synthetic manipulation of 15 steps gives the 44. And finally, we have used DOX resins. You know that DOX resins are being used commonly as controlled source of acid. It has been used to remove the MOM, and also converted the acetonide to give the triol 45. Treatment of this 45 with methanolic potassium carbonate give the target lactam, that is 7-deoxypancratistatine. For further application, you may also visit page number 30 of Green Protective Groups in Organic Synthesis. I can show you the book here. So page number 33, 30, let me look, 30, sorry. So page number 30. अब यहाँ पे आपके पास मोम इधर उसकी फॉर्मेशन और क्लीवेज दोनों डिस्कस की गई हैं. There are number of methods by utilizing all the reagents, giving the reference of each of the reagents where it has been first utilized. First method we have already discussed, mom chloride diisopropylethylamine 0 degree Celsius. It has given 80%, 86% yield. और भी मेथड हैं. अब मैम क्लोराइड के साथ सोडियम हाइड्राइड THF 80% यील्ड में इस्तेमाल कर सकते हैं. एंड ये अगर आप थोड़ा सा चौथे मेथड के ऊपर गौर करें, दे हैव यूज सोडियम हाइड्राइड विच इंक्रीज द रिएक्टिविटी ऑफ मॉम क्लोराइड. So they have prepared mom iodide in situ. You mean you have taken mom chloride and utilized sodium iodide in situ to get the mom iodide. So this mom iodide can facilitate the production of tertiary alcohol. So here are number of methods which are reported in the literature for the incorporation of mom groups. You can get all these references, you can study, you can take out the examples. There are almost 27 methods for its formation, and now there is a cleavage. So yeah, as we have mentioned that methanol in the presence of ICl can also be used for its deep protection. Isopropyl alcohol can also be used instead of methanol in the presence of concentrated ICl. Here the yield is 65%. So here are the methods as well as some discussion. You can go through this, you can download paper of your interest. You can see, especially while you are working in the lab, you can carry out any of this method in order to protect your substrate. So it will be helpful in your research. So here are the references. So remember the page number 33 to 37 for mom protecting group. Now we come on to the second ether, that is MTM. Basically it is just like the mom ether, but here we have replaced the oxygen with sulfur. So it has become methyl thiomethyl ether, or its general formula is OCH2SME. Here is the installation. We have treated alcohol with sodium hydride, followed by the treatment with chloro thiomethyl ether. So we can get the OMTM group onto the alcohol. We can alternative method, you can use DMSO, acetic anhydride in acetic acid. So here are the two most common method I have mentioned here. You can also get some other methods which from the books, Green's protective groups in organic senses. So let me go to the slideshow. Here is the method for the removal. MTM group can easily be removed by using mercury salt, that is a Lewis acid. So you can say that this is somewhat sensitive to Lewis acid, especially the mercury salt. So you can get back your alcohol. Alternatively, an iodomethane can also be used in mild basic solution. So here is the application. The application is in the core synthesis of erythronolide A. Erythronolide A, as you know, is a parent erythronolide. From the name you can say, you can remind erythrocene. It is a parent of several classic antibiotics including the erythromycin. So core during its synthesis of erythronolide A, it has used the MTM protecting group. The OH, this OH group in compound 47 is converted into MTM derivative 48 by using chlorothiamethyl ether and potassium hydride. which ultimately allowed the construction of trace MTM lectone 49. Final step is the removal, that is the treatment of this trace MTM lectone with potassium carbonate and iodomethane in aqueous acetone, give triol 50 in 80% yield. This triol 50 was subsequently used for the preparation of erythronolide A derivative. So for further reading, further application, you can get page number 38 in Green's protective groups in organic synthesis. I can show you that. Page number 38 is here. So methyl thiomethyl ether. I think I have skipped the features. I just have to see where are the common feature of MTM. Yes. I just forgot to explain this slide. Here are the key feature of MTM, that is basically, as I have told you, that it is a variation on the MOM group, that is we have replaced thio, the sulfur with the oxygen, so it has become methyl thiomethyl ether or OMTM. It is much more stable for against the acid than our MAM group, that is the pH range is 1 to 12. For MAM you have known that it is 4 to 12. It is also stable to nucleophile, organometallic reagents, hydrides, etc. However, it is somewhat sensitive to very strong aqueous acids and Lewis acid, especially mercuric salt. This salt has been used to remove the or the cleavage of the OMTM group. It is also sensitive to many oxidizing agents. So here is the detailed procedures or the references for the formation of MTM group. For example, in the first method they have used sodium hydride DME, thimethyl chloride and sodium iodide at 0 degree centigrade, 1 hour to 25 degree centigrade, and 0 degree centigrade for 1 hour, and then at room temperature for 1.5 hour, and they have got 86% yield. So there are many methods. They have also used DMSO in many methods for the as a solvent. So you can get reference, download papers and see the details. Here is the methods of the cleavage. At the top one, that is the mercury chloride, the Lewis acid, which has been applied in the presence of acetonitrile water, 25 degrees Celsius, 1 to 2 hours, and here look at the yield. It is 88 to 95%, which is a good yield. So there are other methods which have been applied for its cleavage. So here are the reference. If you want to get the complete paper and get the examples, you can get from here. So thanks a lot. In the next lecture we will discuss some other protecting groups. So I am stopping recording.